Welcome to another video by AskMath.com. Let's read the directions to this problem. For each ordered pair, identify whether or not it is in the solution set for the system of inequalities. Given 2 minus x is less than 0 and y is greater than or equal to x minus 3. The ordered pairs that were given are negative 5, 1, 2, 0, and 3, 1. Now, we're actually doing 3 problems here. On a test, you might have been given just one ordered pair to check. We're just going to do the same type of problem 3 times with different ordered pairs. And remember that a system of inequalities just means that you have 2 or more, in this case 2, inequalities. And they're inequalities because they don't have equal signs in them. They have the inequality symbols, so a less than in this case, or a greater than or equal to symbol. And so those are called inequalities, not equations. To identify whether or not an ordered pair is in the solution set just means that you are going to take an ordered pair, the x, the y values, and substitute the x value in for the x's in the inequalities and the y value in for the y variables in the inequalities, and then determine whether or not the inequality symbol is true. So if the left side is in fact less than 0, then that would be true, and if it's not, then it would be false. If you get a true statement, that means that the ordered pair is a solution for that inequality. If you do the same thing for the next inequality and it's true for that, then it means that it's a solution for the system of inequalities. Okay, so I'm going to set up my 3 different problems just to remind myself these are 3 separate problems: negative 5, 1, 2, 0, and 3, 1. These are the ordered pairs I'm going to check. There's my 3 problems. And I'm going to substitute them in to the inequalities. So 2 minus x, where the x was, I'm going to have parentheses because I'm going to substitute a value in there. And y, parentheses, greater than or equal to, use parentheses instead of the x, minus 3. And I'm going to do the same thing for each of these problems, so I'm just going to set those up right now. They're all going to look the same. It's just a matter of using a different ordered pair. Okay, so now my job is just to evaluate whether or not the inequality symbol is true once I plug in the ordered pairs. So in the first inequality, we just had an x variable, there was no y, and so I'm going to plug in a negative 5 where the x was. And be careful, on this one, remember that the y came first, so we're actually going to plug in the 1. This is the y value, don't forget, x, y, right? The 1 goes there, and the negative 5 goes where the x was, there on the right side of that inequality. And I'm just going to go ahead and do that for the rest of the problems. So the x goes here, and in the next one, the x goes on the right side. And the y goes here. The x goes here, and the y goes there. Okay. It's a good idea to always write these problems down, especially when you have minus signs or negative signs in the inequalities in the problem that you're given, as well as in the ordered pairs that you're given. That can get pretty confusing if you don't write it down. So if you want to make sure that you get the problems right, it's usually a good idea to write them down on paper. Okay, so now we're going to evaluate using PEMDAS, which is the order of operations, forwards when you evaluate, also called simplify. And there's nothing happening inside the parentheses, and there's no exponents, but there is multiplication. Remember that when you don't see a number, it's an invisible 1, and that is multiplication. So we're going to multiply first. Negative 1 times negative 5 makes 2 negatives times 2, so negative times a negative makes a positive. 1 times 5 makes 5. Then we write the 2 there. 2 plus 5 is 7. Is 7 less than 0? No, it's not. We don't have to do the next problem because we know that this ordered pair is not a solution to this inequality. That means it's not a solution to the system. You would have to have it work for both, and because it doesn't work for the first one, we can just end the problem and say, nope, it's not a solution to both of them, to the system. On to the next problem. Again, minus sign without a number is actually an invisible 1, and that is multiplication. And a negative 1 times a positive 2, negative times positive makes negative. 1 times 2 makes 2. Now I'll write that 2 there. 2 minus 2 makes 0. Is 0 less than 0? No, it's equal to 0. So this is also false. And again, we can skip the next problem, and we can just say, nope, that's also not a solution to the system. And the last one, this is a negative 1 times 3. Negative times positive makes negative. 1 times 3 is 3. 2 minus 3 is negative 1. Is negative 1 less than 0? Yes, it is. Now, because this one worked, we have to go ahead and check the next one to see if it works. Is 1 greater than or equal to 3 minus 3? Well, 3 minus 3 is 0. Is 1 greater than or equal to 0? Yes, 1 is greater than 0. And because we have two smiley faces, this ordered pair, in other words, was a solution to this inequality and was a solution to this inequality. It is in the solution set for both inequalities. So the answers to the three problems are no, no, and yes. They are not in the solution set for the system, and this last one is in the solution set for the system of inequalities. Alright, thanks for watching another video at askmath.com. Don't forget to go to www.askmath.com and check out the rest of the videos.